In this lesson, we will be dividing monomials. Just to quick review what a monomial is, it can just be a digit, it could be a variable, it could be a combination of both. Remember, it can include fractions as long as the variable is in the numerator. If the variable is in the denominator, it is not a monomial. Just a quick review. We talked about multiplication. This is 4 3's being multiplied together. And this would be 6 4's being multiplied together for a total of 9 4's being multiplied together. So you get 4 to the 9th power. Now we're going to switch to division. Well, as in multiplication, when I have 5 to the 7th power, it's the same as saying 5 times 5, 7 times. Oops, I wrote 7 because I was counting. Over 5 cubed, so I would have 5 to the 3rd power, or 5 times itself 3 times. When we look at division, if you think back to when you first were learning fractions, if I gave you the fraction 5 over 5 and asked you to reduce or simplify, you would know 5 over 5 really equaled 1 over 1, or 1. Oh, well now I have another 5 over 5, which can be simplified to 1. Ooh, another 5 over 5, again, that equals 1. Now I have run out of 5's in my denominator, so I am left in the numerator 4 5's being multiplied together, so I get 5 to the 4th over 1, or you can simply just say 5 to the 4th. Another way to look at it is I could do 5 to the 7 minus 3, 5 to the 4th power. The same will be true when it comes time to dividing with variables. X to the 5th, remember, is the same as having 5 x's being multiplied together. X squared is 2 x's being multiplied together. This one reduced by that one is 1. This one reduced by that one is 1. So I have 3 x's being multiplied together to get x cubed, and you could think of that as 5 minus 2, which is x cubed again. 5 minus 2. As in multiplication, you can look and combine and do math if the bases are the same. Here I have x's over x's. I have 7 x's divided by 1, that invisible 1. So I would have x to the 7 minus 1 power, which is x to the 6th. Then when I look at the y's, because the bases are the same, I can solve that. I have y to the 5 minus 4, which is y to the 1st power. We are not going to include exponents of 1, so x to the 6th y. When we work with divisions and we have coefficients in the beginning, you're going to simplify or reduce this as you've known how for a long time. 12 divided by 3 is 4. Now I will move to m's because the m's have the same base. 4 minus 3 is 1, but we are not going to write the 1. And then we have n squared divided by n, and we get n. On the next one, again, you will work with like bases. X to the 9th divided by x to the 5th. you think of 9 minus 5 is 4. Y to the 7th divided by y to the 4th. 7 minus 4 is 3. And then finally I get z's. Z squared divided by z squared is, 2 minus 2 is 0. So we can just leave that one off. You do not write 0 to, or z to the 0 power. Now I'd like to just take a minute and talk about what do you get when you really take x cubed divided by x cubed. The answer is not 0. In the numerator, that's x times x times x. In the denominator, x times x times x. So let's simplify this one little step at a time. X divided by x is 1. X divided by x is 1. X divided by x is 1. 1 times 1 times 1 is 1. 1 times 1 times 1 is 1. Therefore, x to the 0 power equals 1. Now, I'm curious. When we get to using numbers like 5 cubed, so I will apply the same thing. This is 5 times 5 times 5. This is 5 times 5 times 5. 5 over 5 equals 1. 5 over 5 equals 1. 5 over 5 equals 1. So again, 1 times 1 times 1 is 1. 1 times 1 times 1 is 1. So I would get 1. 5 cubed equals 125, so I could simplify it. 125 over 125. That equals 1. If I did it using exponents, remember it is 3 minus 3. I get 5 to the 0 power, but we just proved to the 0 power equals 1. Therefore, anything, variable or number, anything raised to the 0 power equals 1, not 0. I would like you to pause the video and try these 3 problems by yourself. Take your time, do your personal best. Remember to look for common bases. Go ahead, pause the video, do those 3 problems.